Day 17 of 365. Today we kill a problem that wrecks people in interviews. Longest substring with at most k distinct characters. Your first instinct is 2 nested loops. Pick every start, scan every end, count distinct. That's O, n squared. And on a string of length 100,000, LeetCode hands you time limit exceeded. The fix isn't a smarter inner loop. It's variable sliding window. And once it clicks, a whole class of medium-hard problems collapses into one template. Stick around. By the end, you'll have that template memorized. Here's the brute force trap, concretely. For the string isiba, with k equals 2, the nested loop approach rebuilds a character count from scratch for every starting index. Start at 0, scan forward, reset, start at 1, scan again. You're recounting the same characters over and over. The window of work you already did gets thrown away on every outer step. That wasted recounting is exactly what variable sliding window eliminates. We never look backward. We never reset. The model is 2 pointers, left and right, defining a window over the array. Right always moves forward, expanding the window and pulling new elements in. Left only moves when the window becomes invalid, when it violates our constraint. So the rhythm is: expand right until the window breaks, then shrink left until it heals. That's the whole idea. The window is a contract. Right grows it, left enforces it. Every longest valid subarray problem is this same loop. Only the definition of broken changes. Let's build it in Python with a counter. We track a dictionary of character counts inside the window. Loop right from 0 to the end. Do count s, right, plus equals 1, adding the new character. Now check the constraint. While len, count, is greater than k, the window has too many distinct characters, so we shrink. Do count s, left, minus equals 1, and if that count hits 0, delete the key so len, count, actually drops. Then left plus equals 1. After the while loop, the window from left to right is valid, so we update our answer with right minus left plus 1. That's it. 15 lines, fully correct. Pause on the shrink step, because this is where people break it. After every single right move, we ask, is the window valid now? If not, we shrink, possibly multiple times, until it's valid again. The while loop, not an if, is what guarantees correctness. And deleting the key when its count hits 0 matters. Len, count, is our distinct character signal, so a stale 0 count key would lie to us, and the whole thing falls apart. Now the payoff. The template is stable across problems. Swap the constraint, and you get a new solution for free. At most k zeros after flips, drop the counter, track a single 0 count integer, shrink while 0 count exceeds k. That's maximum consecutive ones with k flips. Picture a packet stream where you flip up to k corrupted bits. Want minimum window substring instead of maximum? Same 2 pointers. But now you shrink to find the smallest valid window and record the minimum. Same skeleton, different bookkeeping. That minimum window version adds one trick worth naming: a need versus have counter with a formed variable. Instead of rescanning the whole frequency map on every shrink to check validity, you increment formed only when a character's have count reaches its need count. One integer comparison tells you if the window is complete. That bookkeeping is the difference between true O, N, and O, N times alphabet. Interviewers notice which one you write. Here's the complexity argument they actually want to hear. Right moves forward N times, total. Left moves forward at most N times, total. Neither ever goes backward. So every element enters the window once and leaves at most once, 2 N operations, which is O, N, time, O, K, space. Say that sentence in your interview, and you've shown you understand why it's fast, not just that it is. Day 17 done. The takeaway: variable sliding window is one loop. Expand right until it breaks, shrink left until it heals, and broken is the only thing that changes per problem. Tomorrow we hit the exactly K gotcha, where it most quietly betrays you. Subscribe for day 18.